Thank you, Jenny. Good morning, everybody. Thank you very much for tuning in. As Jenny said, I'm at the University of Miami, and I'm one of the co-organizers, Alison McDonald, of the U.S. CLIVAR post-panel webinar series. And as you heard previously, the panel's mission is to improve understanding of climate variations in general, and we have several priorities that we're trying to address, and one of them is the interaction between the large-scale and coastal-scale climate processes in general, and in particular, the sea level along the coasts. And so today, that being said, today our presenter is Ricardo Domingues, who, in terms of a little short bio, obtained his Master in Meteorology and Physical Oceanography from the Rosenstiel School of Marine and Atmospheric Science from the University of Miami in 2016. Currently, Ricardo is the Senior Research Associate at AOML, which is a laboratory of the National Oceanic and Atmospheric Administration, and he holds this position through the Cooperative Institute for Marine and Atmospheric Studies, or CMAS, at the University of Miami, and he's been in his position since 2011. So Ricardo is involved in many projects at AOML, but one of his interests lies in the study of sea level. And as such, Ricardo was just the co-chair of the scientific organizing committee of the U.S. CLIVAR-sponsored workshop called Sea Level Hotspots from Florida to Maine that actually just took place last week in Norfolk, Virginia. So the panel is very glad that Ricardo agreed on, just after the workshop, to give this seminar to tell us a little bit about his highlights of the workshop. So that being said, Ricardo, please go ahead.
All right. Thank you very much for the introduction, Shane, and also for the opportunity to share some of the highlights and takeaway messages from our recent workshop. This has been a very interesting meeting. We had a very positive feedback from participants, and I also believe we were able to identify some points that we as a community can address moving forward. So one of the main motivations from the workshop come from the fact that several areas along the U.S. East Coast from Florida to Maine, they are already highly vulnerable to recurrent flooding conditions. And we've seen several times in the news that cities such as Miami, Norfolk, and New York, they're already being affected by these recurrent sunny day flooding events. And in fact, observation shows that both the intensity and frequency of these events has been increasing over the past few years, which you can see here on the left, the analysis from several tide gauges along the coast. And the projections indicate that these events are going to further intensify in the future. So on the right, you see a graph with the number of high tide flooding days for Norfolk, and according to the intermediate scenario, by 2050, we should have flooding conditions every other day in Norfolk. So this was one of the main reasons we chose Norfolk as the city to host our workshop. Norfolk is actually the second city in the nation in terms of vulnerability to flooding conditions, just after New Orleans. And also it's one of the cities that is taking the lead in terms of adaptation efforts, and as it was also the first city to name the first coastal resiliency officer in the United States. So with that said, so really the main goal of this workshop was to provide a meeting space for those working at the forefront of the research and adaptation efforts related to sea level changes. And we know that sea level changes and adaptation is a very complex topic that requires the involvement of a broad range of professionals such as climate scientists, local modelers, developing high-resolution applications, engineers, policymakers, and also these resiliency officers and other adaptation professionals. So these professionals, they not always have an opportunity to meet and exchange information, so we really wanted to address this need right up front in this meeting. So the organizing committee has identified a few key questions sort of to help us guide us through these 2.5 days of the workshop. So the first one being we wanted to understand what are the efforts already in place aimed at mitigating the effects of sea level rise. Second, where are we with the science? What do we know about the drivers, the uncertainty, and the future of sea level rise? The third one was, what are the tools and monitoring resources currently available? And finally, what are the best practices for linking science information with decision-making support tools, and what are the gaps that need to be addressed? So we have organized the agenda in a way to sort of directly address these questions. We focused also, instead of having a large number of talks, we want to really to have a lot of opportunity for discussions. So we have identified a few key speakers that could do a nice coverage not only of their work but also from the work being developed by the community. And we also tailored the agenda to have most presentations happening the first day of the workshop, with both sessions 1 and 2 and the lightning talks and poster session. And we did it that way sort of to establish the baseline for the discussions that would happen mostly on the second day of the workshop. And so, yes. So we had a very nice number of participants with 62 participants, 14 invited talks, and 28 poster presentations. And what was really interesting is that we really captured these broad range of professionals working with sea level. So we had about 40% come from the university community, 26% from federal agencies, about 18% from sea level practitioners, and we're defining that as those professionals who are actively engaged in policy or in the implementation of adaptation efforts, about 11% of private companies, and 4% of nonprofit organizations. And so in terms of these questions, I just wanted to provide a brief overview of what we learned. We had the first 3 sessions directly address these first 3 questions, and then with the discussions we were able to get some information for the 4th question. So with respect to the adaptation efforts, we had 6, I should say, very high-level speakers that presented some of the very advanced work that is being done in terms of adaptation and to improve coastal resiliency. And what we learned is that these adaptation efforts, they're really based on 3 pillars. One being policy development, the second one design, and also of infrastructure and of solutions, and also the third one is really protection, so implementing some of those solutions. And so we learned that also these efforts, they really required very detailed and high-level information at the local level. And that's because the solutions, they will really depend on the specifications of each location. So really detailed assessments have to be carried out on how to implement these solutions. And most of these efforts, they are planning for timescales from 30 to 50 years, which is typically the lifespan for utilities. However, we did talk on how homeowners require short timescales. And also the implementation, we had several engineers in the audience as well, and we had some very nice discussions on how implementation oftentimes requires picking one specific sea level rise projection and having and implementing that associated with specific levels of risk. So I'm just showing here is a very simple example on the right of how that would work more or less. And really, we did learn also that multiple scenarios, they're useful because, for example, they may decide for using a projection from the higher end for more critical infrastructure, such as a power plant, whereas they may also decide for using a projection from the lower end if it is an infrastructure that's not going to have a huge impact. However, what we did discuss that guidance is needed in terms of how to make those choices and also how to associate specific levels of risk for this projection. We also talked about how the probabilistic information can be useful to communicate with stakeholders, and engineers will tend to convert that information to risk. A lot of these implementation, they also they include very detailed assessments of the cost effectiveness of these adaptation efforts, and so oftentimes they will evaluate the cost of doing nothing and compare that with the cost of building infrastructure and how much benefit you can get from that. In terms of challenges, one of the main challenges is really the elevated cost of adaptation, which can be sometimes 100 times larger than just the cost of carrying out the study by itself, or even more. And so there is, and we heard a lot that there is still a lack of sustained and integrated funding from the federal and state governments. Another main challenge is really associated with these regional and local characteristics. And just as an example, here in Florida, we have the limestone foundation prevents some solutions such as building a seawall or a levee system from working because of the very porous bedrock. So basically, it works as a sponge, and water can go right underneath. And another challenge is really associated with the lack of awareness. We've heard a few examples on how stakeholders sometimes they don't distinguish between sea level rise and other reasons for coastal flooding. And having that awareness developed is actually very important because it's really important to have involvement from the constituents, since they can oftentimes drive the political will to implement these adaptation efforts. So now moving quickly here on what we learned, what we discussed from the science part. So in the first talk of the science section, Chris Pykush from Woods Hole, he talked about how sea level changes along the U.S. East Coast can vary regionally, and also on why rates in some of these locations are faster than the global average. He touched on the mechanisms accounting for some of these changes, and also on how some of those are highly predictable in human timescales, such as, for example, the glacial hydrostatic adjustment, which basically works linearly in human timescales. So there is a very low level of uncertainty associated with that, while others, such as changes in ocean dynamics and melting ice sheets, are generally surrounded by larger uncertainties. So in the second talk, Erica Lentz from the United States Geological Survey, she talked about how the changes in the coastal landscape, they're variable and they're also dynamically coupled with the effects of sea level rise. That's something that's not always natural to think about, but she really gave some really nice examples on how these changes are already being observed in some areas, and also how approaches based on Bayesian networks are helping to model and project some of these changes. We'll see later on that the USGS has an interesting tool where you can see which sections of the coast are actually more vulnerable to some of these changes in the coastal landscape as a response to sea level rise. And then in the third talk from the science section, Nathan Urban from Los Alamos National Laboratory, he addressed the potential use of uncertainty quantification in helping improve the synthesis products being used by the community to plan for sea level rise. So he described how some process studies, such as those based on targeted and idealized simulations and high-resolution simulations, oftentimes they tend not to be included within those synthesis products, and how that could be improved by building these integrated modeling networks to improve overall uncertainty. And he also touched on the importance of acknowledging how complex these adaptive systems are, which oftentimes involves various sectors, multiple planning agencies, and really an interconnected web of decisions where impacts can oftentimes cascade down. So he described on how computational tools can largely help us search through this very complex web of decisions and help plan and help identify the best solutions and plan for adaptation. And then in terms of tools, we have addressed, we had a broad definition of tools. So we talked a little bit about some of the web-based tools which are assisting planners with analyzing some of the data and also to have access to the sea level projections, sea level changes, and also to see which locations of the coast are mostly vulnerable or are prone to flood. And I just included a few examples here from NASA, NOAA, USGS, and also from the Virginia Institute of Marine Sciences. We will have a more comprehensive list included in the final report, and so I encourage you to take a look at that. We also talked about, in terms of observation networks available, such as the tide gauges, rainfall gauges, which are also very useful and important to access the contribution from compound flooding. And also we talked about some new technology, some new development of sensors that are low cost and that are already being used in some cities such as Savannah and Norfolk as well, and also how those are helping to monitor our water level in a more integrated way and also identify which areas of the city are already flooded or prone to flood. And there were also a few examples of citizen scientists and also open data phone applications that are being developed, which really are a good vehicle for community engagement and are also collecting very useful data that is actually already being used to validate some high resolution and localized modeling applications for storm surge, for example. And we also talked about, in terms of decision support tools, Obey, he talked very nicely how some of statistical and computational frameworks are being used to help in the decision process for some of those complex systems that have cascading impacts. So really to help us choose the best route with adaptation. Okay, so I wanted to also mention here that we, in addition to these talks, and we had obviously very productive discussions, and we had a very nice poster presentations. So I encourage you to take a look. We have already, most posters are available online. So I would encourage you to use this link and take a look of some of the work that was presented in the workshop. And finally, with respect to the last question on what are the best practices and also what are the gaps that need to be addressed, we came up with a few very comprehensive lists of some of the gaps and needs for the future. I'm just going to read through this. I'm not going to describe in the details because of the time, but I'm just going to read through these research needs. So there is a need for exploring the role of integrated model approaches in reduce uncertainty, formalize and advance the field of decision science, advance the science field of climate adaptation, improve observational and modeling capabilities to reduce decision-relevant uncertainty, and also improve understanding of drivers of interannual variability, such as storminess and natural climate variability. Also improve the understanding of the relationship between tidal range and erosion processes, improve the seasonal to interannual sea level forecast and probabilistic distributions, and assess the effectiveness of green infrastructure in improving resiliency. The green infrastructure is oftentimes being adopted to help with protect the coastline, but also to serve as water storage in some areas. So, but following our discussions, we really thought there is a need to further improve how effective these infrastructures are. And a better definition on the relationship between groundwater and sea level rise. Several locations, this is a very important topic as well. For example, here for South Florida, a lot of some of our drinking water supply are actually quite vulnerable to these. So it's really important to understand how these two are coupled. And also improving the understanding on compound flooding probabilities, and also improve the understanding of feedback between ecosystem health and sea level rise. In terms of needed improvements, I won't spend much time here, but like I said, we'll have this complete list included in the report, and also this presentation will be made available. But I wanted to say that we've had several discussions with the adaptational professionals, and they're really useful to have the multiple scenarios. However, oftentimes there's little guidance on how to actually use those, and so there is a need for additional educational resources, and also for establishing a coherent set of standards on how to use those different projections, not necessarily at the national level, but at the regional level. That could very much be helpful for them. And in terms of recommendations, we really saw a benefit from having these type of events. So we are really encouraging additional opportunities for having similar events in the future. Also, there is a real value in maintaining the current network of sea level observations and also other auxiliary instruments, and also to implement new observations of the coupled natural human systems in support of the long-term records. There's also a need to establish a clear institutionalized framework to move science information into actionable decision-making support tools. We believe that there will be a benefit from having sustainable funding opportunities for these adaptation science and efforts. And also, we believe that it would be helpful to have opportunities of research funds available at the local level to foster these adaptation efforts. And so we saw some very nice examples from really people carrying out very advanced work in terms of adaptation. So we really believe that there was an overall agreement that it would be very nice to implement these research grants tailored to identifying and rewarding some of these talented professionals working with adaptation. So finally, we saw that based on several successful examples that there is really a benefit. There would be a real benefit of establishing these regional networks for adaptation. Why? We heard several times during the workshop that there is no one-size-fits-all. In other words, having something established at the national level does not necessarily meet the needs for the local level. So having these regional networks can really help address these hyper-local issues that are inherent to particular locations such as groundwater modeling, compound flooding, and storm surge vulnerabilities. And also will help enable regional standards for adaptation and also support municipalities with limited resources and low availability to address with technical capacity. And one of the potential ways would be to have funding opportunities that require a co-production proposal process to really engage these different parts of the puzzle together and work on solutions. And it's not that already doesn't exist. There are already opportunities like that, but what we heard is that what's already out there is largely insufficient for addressing all the needs. And so this is just a simple diagram that we came up with. So really having at the regional and local level, having the experts, the science experts, engaged with these sea-level practitioners, which would enable like regional expert and advice and also up-to-date science information delivery. And also, on the other hand, have the feedback on needed improvements and also have the opportunity to develop more user-driven science. And that is also, of course, engaging actively these boundary organizations that they play a very critical role, not only connecting, but also translating and also facilitating these dialogues. And then at the national level, we really believe that there is a need to establish a network for the exchange of up-to-date information on sea level changes relevant to the United States. We have a very strong community within U.S. working with sea level, and so, but there isn't any institutionalized effort, multi-agency, and also engaging the university community to discuss sea level. So we really think that there will be a benefit having something like that in place, and also something similar for the adaptation of professionals. So some final remarks. Here's a brief timeline for the workshop report. We will have a public comment period to allow for us to really refine to make sure we're reporting on what are the needed, the most important needs for the community. And so I would encourage you to take a look and also provide your feedback. And we'll also include a list of tools and resources in the report. And we're also exploring a possibility to have a white paper come out of these. And finally, we have the invited talks and poster gallery online. So please go ahead and take a look. So I believe that's all I had to say. Thank you very much for listening, and I'll take questions.
Thank you, Ricardo. So as a reminder, use the raise your hand feature in ReadyTalk if you have any questions, and I will take you off mute to ask your question. Or you can also type your question into the chat box, and I will ask it for you. So with that, any questions? Okay. So yeah, I see a question from Tony Lee. Let me take you off mute. All right, go ahead, Tony.
Hi, thank you very much, Ricardo, for the very nice summary of the workshop. And I have a question about, let's see, slide on the research needs.
Right. Okay.
The first bullet, explore the role of integrated model approach.
Right.
To reduce uncertainty. And could you clarify what the integrated model approaches mean here?
This is what I was explaining a little bit on the. That's a good question, Nathan. Oh, I'm sorry, Tony. This was what Nathan covered a little bit, and he talked about on how oftentimes these really high resolution and high level process studies, they're not oftentimes not included in the synthesis products such as climate simulations that will make into the report. So they're not always included, for example, in the parameterizations and all that. So he really talked about how having a deeper integration of these process studies and high resolution applications with these long-term climate simulations to improve and reduce uncertainty. Not sure if that answers your questions. I'm not the expert on the topic. That's actually one of the challenges in this, in having these exchanges, because we have a very broad community. But so it's really was a good opportunity to see the needs from the different sides.
Yeah, thank you for explaining that. So I guess one of the examples is GIA effect and self-loading and attraction effect, self-attraction and loading effect. Those are all those are effects that are missing from many ocean models.
Right.
Or therefore climate models. So I guess those are examples of the need to enhance the integrated model approach.
Exactly, and also to have the most updated information. Chris Pykush did also cover a little bit on that, but yeah.
Right.
All right.
Yeah. Thank you.
Right, and I see one question from Shane. So go ahead, Shane.
Ricardo, thank you very much for putting together this overview presentation so quickly after the workshop. So I think I gathered from your talk that you identified, or the workshop participants identified, some maybe missing observations such as rainfall or erosion processes. Do you recall any identified need for measurements or observations of sea level itself?
I'm sorry?
Do you recall?
Repeat? Yes.
In the workshop, did you guys identify a need for a different type of better sea level observation, such as, better distribution in time and space, or do you think we have the information we need at this stage?
So we saw that from a few examples in the workshop that there's a real benefit from having these regional or very local networks of sensors, of water level sensors, so that can help with, for example, they're being integrated into applications to send out warnings to residents in real time. So that's a real benefit, and I think that would be a valuable addition, not necessarily at the national level, but really coming down to the local level. So there's a few efforts that are developing these sensors, and a few companies as well. Yeah.
Thank you.
And one last question from Cecile. Let's see. Cecile, could you type in your question, as I don't see your name on here for audio?
The conference has been unmuted. The conference has been unmuted.
Cecile, could you ask your question?
Can you hear me now?
Yep, we can
Yes.
hear you.
Oh, good. So it's not so much of a question, but more of a comment to link back to the suggestion you have that there is more effort to connect the science and the stakeholders community.
Right.
And so there is the Earth from Space Institute, which is a new institute that has been founded by the University Space Research Association, who is a non-profit. And we're going to be organizing a workshop on sea level rise between, so a meeting between stakeholders and scientific community in November, I believe, in Columbia, Maryland. And I'm very interested in the suggestion you have made, and I was wondering if you would agree to maybe send me your presentation or maybe join one of our telecon where we organize that workshop, so you can maybe have some suggestion about what you learn from your workshop, similar to what you give here, and help us make it a more successful workshop.
Yes, yes, thank you very much. I think we really need these types of events happening more often, and I'll be happy to join and maybe share a little bit of my experience as well, our experience really. And so this presentation, I understand we can make it available. Janie can confirm on that. We can. So, but yes, for sure. Thank you.
I'll send you an email. So my name is Cecile, and we'll get in touch that way. Thank you so much.
Wonderful. Thank you.
Hi, this is Mike Patterson. I want to jump in on that point as well. So we also learned at the workshop that there's an upcoming, another upcoming workshop being organized by NOAA to be held in Norfolk within a month's time or so. And there was a recent workshop organized by NASA in Annapolis on the East Coast or Regional Sea Level, where they held their science team meeting. And also had a focus on the applications interface. So what we're seeing, I think, within the community is this across from several different quarters of the community, an interest in engaging both on the science and the adaptation challenges of regional sea level rise on the East Coast, and we need to capitalize on those efforts. But also, I think this really points to this, the point that Ricardo made, the need for coordination at the national level. Improved coordination, so that we're sequencing efforts and getting the community together in a more streamlined and coordinated way. And we're not continuing to come back. There was the term adaptation fatigue or something, or stakeholders fatigue at the workshop, relayed in terms of always going back to the same people to get their inputs for our science planning again and again in rapid succession, and our coordination on our end and helping to set up a structure for better coordination nationally, I think is indicated by all these efforts. I'll stop there.
Okay. So with that, any final remarks or questions? All right. So thank you, Ricardo, for presenting today, and thank you for everyone who participated as well. So we really appreciate you taking the time and informing everyone about your research, Ricardo. As he said, we will have all the presentations on our website, on US CLIVAR's website, by tomorrow. So if you want any additional information regarding any of the presentations he presented over, they will be on our website. We will also have a report coming out within the next few months with this. So keep an eye out on our Twitter account, our newsgrams, and we'll have all of that listed. So with that, thank you, everyone.
Thank you very much for the opportunity.